In this video, we're going to have a look at calculations involving the angles of elevation and depression. Now, the angle of elevation is the angle measured up from the horizontal line to the line of vision. So it is starting at the horizontal line down at your line of sight, and it is you looking upwards. And the angle of elevation is this angle that is formed between your line of sight and your line of vision, you looking upwards. So think of it as you standing on the ground and looking up to the top of a cliff. You are looking up, you are looking at an angle of elevation. The opposite of an angle of elevation is an angle of depression. And this is the angle that is measured down from the horizontal line to the line of vision. So here, you are starting at the top and your line of sight is up the top, and you are looking downwards. And the angle that's formed between the horizontal line and the line of sight looking downwards is the angle of depression. So this time, instead of standing on the ground looking at the top of the cliff, which gives you your angle of elevation, you are already standing at the top of the cliff and you are actually looking down to the ground. So you are looking down, and the angle that is formed is the angle of depression. So let's have a look at some steps to calculate the angle of elevation and depression and use them to solve problems. So the first step when solving problems involving angles of elevation and depression is to read the question and highlight any key information. Now, this information could be a distance or an angle that is provided to you in the question. The second step is to draw a diagram. Now, that diagram would normally involve a triangle, and mark down any known measurements or angles. Once you have done your diagram, you can use trigonometry and the angle of elevation or depression to solve the problem. So let's have a look at an example of how to solve a problem involving an angle of elevation. In this example, a person on a ship observes a lighthouse on the cliff, which is currently 830 meters away from the ship. The angle of elevation to the top of the lighthouse is 12 degrees. So we want to calculate how far above sea level is the top of the lighthouse. And if the lighthouse is 24 meters tall, how high is the cliff? So when I was reading the question, I highlighted some key information, and I know that I'm on a ship and I can see a lighthouse on top of a cliff. The cliff is 830 meters away from the ship, and the angle of elevation to the top of the lighthouse is 12 degrees. So my next step is to use that information to draw a diagram. So I'm going to draw my ship, and I'm going to draw my cliff, and on that cliff is a lighthouse. And it has light coming out of it. All right, so now I'm going to use that to form a triangle. And I know that my angle of elevation from the ship, so this angle here to the top of the lighthouse, is 12 degrees. And I know that my ship is 830 meters away. And what I'm wanting to know is how far is the top of the lighthouse from sea level. So I'm looking to calculate this length here. So now that I have my diagram, I can use trigonometry to be able to calculate the missing length of that side, which will give me how high the lighthouse is above the sea level. So looking at the information, I've got an angle, I've got the adjacent side, and I want to find the opposite side. So using opposite and adjacent is going to be tan. So I need to use the tan ratio to be able to calculate the height that I am looking for. So tan of an angle is equal to opposite over adjacent. So tan 12, because I'm now substituting in my known values, is equal to, opposite is still my unknown, over 830. So rearranging that formula to get O by itself, and I do that by timesing both sides by 830 times by 830. I know that 830 times 10, 12 is equal to the opposite side, and I can use my calculator now to find the length of my opposite side of the triangle that I formed. So my opposite side is going to equal 176.42 meters. So the height from the top of the lighthouse down to sea level is 176.42 meters. So now to answer part B, it says if the height of the lighthouse is 24 meters, how high is the cliff? So the cliff height is going to equal 176.42 minus the height of the lighthouse, which is 24. So the cliff height is equal to 152.42 meters. So that is an example of how I can use angle of elevation to solve a problem.